What's up guys, JayzTwoCents here, and you have been bugging me to do the For the Win 3 review from EVGA. This is a highly anticipated card, and if I'm not mistaken, I believe this is the first time EVGA has incorporated 3 fans into the cooler. So when I asked you guys in the last video which graphics card you really wanted me to do, many of you were surprised that I hadn't gotten my hands on one of these yet. You're right, I didn't get my hands on one. I got my hands on 2. Cooler Master's Master Key Pro series of keyboards offer 16.7 million color RGB, genuine cherry switches, a variety of sizes, as well as surface-mounted controls allowing full customization without the need for standalone software. Learn more by following the link down below. Now, if you want your very own EVGA GTX 1080 Ti For the Win 3, it's a long name, then stick around to the end of the video because we are giving away one of these internationally. Well, not one of these are actually mine. These are going into my personal rig. You can't have it, but you can have one exactly like it anywhere in the world where giveaways are legal. So with that said, stick around to the end of the video to find out how. But moving forward, here it is right here, one of the most anticipated cards of the year. It's one of EVGA's, I believe it's EVGA's very first design with a 3-fan cooler, which is kind of neat to see. They've always stuck to the 2-fan design. And what makes this one a little bit unique is so far it's the only GTX 1080 that I've seen that sticks with a 2-slot width. A lot of the cards that we've looked at so far, and cards that I actually have sitting upstairs waiting to be reviewed, and ones that are on their way, are all 2.5 slot. It's a lot of heat to maintain, so they've decided to just go ahead and go with bigger coolers. And because of NVIDIA doing away with 3-way and 4-way SLI as official support, a lot of the motherboards have spaced out their 16x PCI Express slots, which is good because now the cards are separated enough to where the extra thickness isn't going to be a problem. It's only going to be a problem if you're running it on an older motherboard that wants you to put the two cards in the slots right next to each other. If you're running a 2.5 slot card, it's not going to work. Now, I still wouldn't recommend running a card like this sandwiched up against itself like this in a motherboard, because as you can see, you are going to choke off one of those cards very badly when it comes to airflow, and it's going to throttle. So I still wouldn't recommend doing that, but that's just worth mentioning at least. That's the reason why 2-slot and 2.5 slot even matters at all. Speaking of dimensions, it actually measures 11.8 inches long and 5.6 inches high. Now, because I said inches in my last video, you guys wanted to castrate me for using imperial. So I'll go ahead and make the rest of the world happy and let you know it is 299 milliliters. Is that milliliter? We're talking liquids? No? Is that right? By 142.6 millimeters tall. In the last video, I also didn't show any charts, which made some people mad and most people happy. So I'm gonna meet you in the middle. We're gonna put up some Firestrike scores compared to the 1080 Ti's we've already taken a look at on this channel so you can see how it stacks up. And we're gonna go ahead and do that right now. Now, among the 4 1080 Ti's we've taken a look at, and mind you, we still have 3 or 4 more coming through here, this is so far top dog in terms of scores. But as you can see, the scores are all very close enough to where the overall gaming experience in a blind test, you would not be able to differentiate one card from the other. But hey, at least it gives you some sort of an idea of where it stacks up. So what we're gonna focus on today is obviously the cooler and what makes this card still kind of stand out in the market. It still has their ICX9 sensor technology, so it's got sensors on the GPU, it's got sensors on the memory, it's also got sensors on the backside of the GPU, as well as the power delivery, so you can keep an eye on all of the temperatures going on in here. Obviously, that's because of the cooling issue that they had with the For the Win 2 card, which unfortunately led to some hotter than desirable experiences with the graphics card, so that's been remedied here. Not only now have they remedied it with a cooler design, but you can monitor it as well, and they do have patents on that, I believe, so I don't know if anyone else can incorporate that, but it doesn't really matter because you're getting it with this one. So you got 3 fans here. All 3 of these fans are independently controlled by the different temperatures on the PCB. So you have GPU fan curve controlling 1 fan, memory fan curve controlling 1 fan, and then the power delivery controlling the 3rd fan. Now, if you don't want them independent, you can link them so that you can have one fan curve that controls all three. For the testing that you guys saw though in temperatures, they were independently as they come out of the box, no adjustment to fan curve or anything. Literally the settings were out of the box. But anyway, moving on, we've got two 8-pin power plugs on that. That's because we have a 280 watt power draw from this card, up 30 watts from the 250 watt that ships with the Founders Edition card. And you have a dual BIOS. I love that EVGA includes dual BIOS on their cards. I mentioned before that a lot of companies have done away with that and they're now going with these profiles. Basically, they both boost the same. The difference is one has a higher power target, so you have more power draw available to it. But what I thought was kind of confusing though is it's called Master and Slave, and I don't like that. Not that because it's called Master and Slave, that reminds me of the old IDE cable days. What I don't like is it was confusing in that I thought that Master was gonna be the faster power target or the higher power target BIOS, but it's not. The Slave is. So my recommendation to them would be to rename that maybe Standard and OC. That way you know which one is better suited for OC. But anyway, moving on. Since we're here, here's the back plate. Vents where it matters behind the GPU. Vents where it matters behind part of the power delivery. And then where the MOSFETs are, you have a solid piece of metal where it's making contact through heat pads on the back side of the power delivery, as well as the front side. Lots of heat pads, even a copper pipe. We'll talk about that in a second. So you have lots and lots of cooling for the power delivery. EVGA was like, not today when it comes to the overheating once again of the VRMs. I think they took a problem and I think they might have overcompensated a little bit, but that's okay. We like overcompensating for things around here. Now the Founders Edition card took away the DVI in lieu of better airflow for the blower style cooler. EVGA puts it back, which is nice to see, and you still have the HDMI and 2 or 3 display port, which is nice to see. One thing I'm not a fan of though, is I'm not a fan of the size of the font that faces you. It's kind of nice that you've got an LED that lights up this right here, but I think they made that a little bit too big, in my opinion. It's like really in your face, especially when you have 2 of them in a system and they light up, it's really kind of in your face. They are RGB, of course. All the LEDs on the card are RGB, but they are white out of the box. Now on the edge right here, you have the GPU, memory, and power delivery LEDs. Again, you can change the color based on temperature, or you can turn them off entirely if you want. These are just to give you kind of a quick glance idea of what the temperatures are like of your particular components. If you're in a game and you don't have an overlay up, those are there. All right, enough talking about it. Let's go and take the cooler off and show you what's different, because they changed some stuff inside the cooler as well. This is kind of a bitch to get off because it's got 1, 2, 3, 4, 5 power cables that have like no slack on them. You can see right here where they flattened out the pins where it makes contact with the thermal pad, which gives it better adhesion and surface area to touch on the pins when this is responsible for cooling or dissipating the heat coming from the power delivery. Same thing right here where it touches the heat pipe. And that's what I want to talk about next. Check this out. So this is where I said, not only did they like solve the problem, they probably over-engineered it, which I don't know if there's really such a thing, but anyway, I digress. These are the pin fins, and we saw these on the ICX 1080 cooler, but one of the things that the CEO of the company had told me was he didn't think they were tall enough. He wanted them to be taller. So that's exactly what they did here. I mean, look at the additional height of those pin fins. That's pretty ridiculous there. But the idea is to get the heat, again, coming off of the power delivery, up into the airflow right here. You can see how that middle fan pushes down right there. So there's where the middle fan pushes down as well. So the heat is gonna be dissipated out the sides. There's more surface area right here on the pin fins that are pulling that heat up. So they're more of like a cooling tower. And if you know anything about how a heat sink works, it's just about surface area. So let's go ahead and pull this back and see what we got for the power delivery cooling. Look at that. Yeah. So when they say, we're not gonna make that mistake again, this is what they've done. But you can see we have a copper base right here that's touching the VRMs, not just an aluminum piece, or aluminum, excuse me, wherever you're from, but you got a copper base right here with the heat pipe coming back over here as well. So you've got a lot of cooling for the VRMs. That's a big deal. All right, there's only one thing left to do. I don't know, maybe force Nick to put that one back together, and we take this one and we go and play around with it and see exactly how well it overclocks. Here it is right now on the Slave BIOS, which allows a little bit more power target, but we haven't adjusted anything yet. I haven't touched any of the sliders. I got the new Precision X OC running. It's running at 1962 megahertz and 59C. Guys, this is 58, it just hit 58, 59. It's been running now for probably about 45 minutes in total, because we've been doing some testing on this to see if this was something weird happening here. It's the factory fan curve. Now, mind you, on the Slave BIOS, the factory fan curve's a little bit more aggressive, but it's still pretty damn quiet. And inside a case, you wouldn't hear that at all. So keep in mind too, open air test bench testing means the only thing limiting the card's temperature is going to be the card's cooler itself. So make sure if you're putting this obviously in a case, you have good case airflow and you should see similar results. But 58C, 57C, geez, it's like, it has not even hit 60 yet with this particular BIOS. Now on the master BIOS, which is the one that has a little bit less power target and a little bit less fan curve, hit 60C. We never even saw 61. So that tells me we've got a lot of headroom for overclocking. That is freaking amazing. This is what Precision X OC looks like for the ICX cards, especially for the Win 3 cards. You've got 3 fan curves here. If this was a 2-fan card, you'd see 2 fan curves, but you can link them through these little link buttons right here, just like you would SLI cards. You can see the sensor temperatures by hitting the sensor button. Here they are right there. So we can see the power temperature on the back of the card, the GPU temperature, the memory temperature surrounding the card, so you can really keep an eye on what things look like. The temperatures and speeds that you just saw were all based on factory fan curve and factory settings. Now the GPU clock is not idling down because we do have preferred performance mode going in the 3D settings inside the driver, as well as because we're on the slave BIOS too, it's going to keep the fans running at all times. That's one of the differences too between the master and slave. So here's what we're gonna do. We're gonna increase that power target, which is allowing up to 117%. I'm gonna put the priority at temperature, so that's 90. It's never gonna hit anywhere near that. Let's just try a basic 100 megahertz offset on the core, and let's see what happens here. I know the text is really small, but it ramped up to 2076. Temperature is currently at 46C. It takes time for that to ramp up, and we didn't get any immediate crashing. So what I wanna do now is I wanna add just a little bit more frequency. It just dropped to 2063, so it starts kind of high and then it steps down as the temp starts to come up a little bit. So what I'm gonna do here too is I'm just gonna go ahead and add voltage, let the voltage go as high as it can, which is 100%. That basically means you're not increasing the voltage. What you're increasing is how early in the frequency range the voltage will go to its max setting. It's part of that GPU Boost 3.0 curve thing. I'm not a fan of it, but that's just the way it is. We have to live with that. So I'm gonna also bump this up to 125. Keep in mind, I have not had any 1080s come through here yet and be able to achieve anything above a 2088. I'm also gonna go into the fan curve. I'm gonna set it to aggressive. See, and we got an instant crash with an additional 25. So I think we're gonna see about the same headroom, unfortunately, for the Win 3 card as we saw in just about everything. It's kind of funny how the cores, it seems to be a lot less lottery involved. In fact, the lottery now doesn't seem to be whether or not you win. It seems to be whether or not you lose, because most of the cores now reach about the same headroom mark, and then every now and then the loser is much lower. There's very few winners anymore. Well, unfortunately, the second card didn't beat the first one. In fact, it's a little slower at 2025, so this one's about 30 megahertz faster. A difference you wouldn't even notice though if you put these side by side. That's still over 400 megahertz faster though than the actual base clock of that GPU from NVIDIA. So you're still getting a massive amount of headroom because of GPU Boost 3.0. Anyway, if you want to win your very own for the Win 3 ICX graphics card, 1080 Ti with this awesome looking shroud, people either love it or hate it. Either way, I really like the looks of this. When I first saw it, I might have nerdgasmed a little bit. Follow the link in the description of this video. It's a Gleam giveaway. I've teamed up with EVGA. It's really simple. Just follow some social medias and subscribe to the channel, and you would be entered into this worldwide giveaway, except for where prohibited. All the rules and regulations are in the giveaway, so make sure you guys read it. We're gonna run the giveaway for 2 weeks from the day this video airs, which is Friday, May 5th, and then we will notify the winner and we'll go from there. Anyway, guys, good luck. I hope you guys win this card. It's pretty amazing. I've got 2. They're gonna be an SLI. We'll talk about that in the future. But again, click that link. I know you guys are like, you know what? There's gonna be a million entries. I'm never gonna have a chance. But only way you guarantee you don't win is by not entering. So just enter. What do you guys have to lose? Nothing? Gosh. Anyway, time to go, guys. Tell me what you think about the For the Win 3 card. You wanted to see it. I had it all along. I was just teasing it and hanging on to it and waiting for you guys to get all excited about it. And here it is. So with that said, it's time to go. Thanks for watching, and I'll see you in the next one.